So if we want to actually access the accelerometer data, the raw data of position of your device, you can. There's a UI accelerometer object that represents the combined knowledge of the three accelerometers in the device. It's a singleton object, which is a little odd. It means that it always exists. You don't have to create it. You don't have to destroy it. You just have to ask for it. And the way that you do that is by creating a pointer and setting it to UI accelerometer space shared accelerometer. This is a method that you're calling on the class that will give you back this object. Like many things in the iPhone, it works with delegation. So you're really just grabbing it so that you can set its delegate quite commonly to yourself. So in your view controller code, perhaps you grab hold of this shared accelerometer and set its delegate. You then often set the update interval for that to be, in this case, about 30 times a second, 1 divided by 30. The reason that you're doing this is to tell it how often you want to be notified of changes in the accelerometer status. You can go to smaller intervals of time if you want it to be faster, say 1 divided by 70 or 80, or you can go a little slower, say 1 divided by 10, to go for 10 times a second. And then finally, you're going to implement the accelerometer did accelerate method, which is the one that will be called so that you can actually respond to changes in the accelerometer. So how do we do this in code? Well, let's take a look. So I have a simple view-based application. In my nib file, I've just dragged on 3 labels onto the nib. I can blank those all out. And these are going to display the contents of my X, Y, and Z axes from the accelerometer. In my Xcode itself, I have my header file, simply has the entries for these UI labels and the properties for them. What I've also done on line 12 is support the UI accelerometer delegate. I'm basically volunteering here. I'm saying, yes, this view controller of mine can also be a delegate, so that later when we set the delegate, it will actually say, yes, you can do this. You can support these methods of this accelerometer. In the implementation file, I have my synthesize for the labels, for the x-axis, y-axis, and z-axis. Then what I'm going to do is write a little bit of code in my viewDidLoad method. So I'm going to uncomment this and put it before the call to super. I'm first going to grab hold of the accelerometer, creating a pointer called accel. And again, I grab hold of this. I don't have to say alloc or new or init. I just say UI accelerometer shared accelerometer. Then I'm going to set the delegate of it to self, meaning this view controller code. And then I'm going to set its update interval to 1 divided by 30, which should give us about 30 times a second. And that's all I really need to do to actually grab hold of the accelerometer and set its delegate. What I've got to do after this is actually, of course, implement the delegate method that I need to do. So I'm going to paste this after my viewDidLoad. And this is the signature of that method. It's accelerometer did accelerate. And what's going to happen is we get an acceleration object here. It's a UI acceleration object that has an X, Y, and Z in it. And what we can do is use it to set the values of our labels. So quite simply here, for example, I could say that the X-axis label is going to be set to, and I'm going to create a string using one of the convenience methods, string with format. I'll say X is, and the value that I want is actually going to be a double. The UI acceleration object has an X, Y, and Z, and they're all really doubles under the hood. So I'm going to use the format specifier of %f, comma, acceleration dot, and if we look at that, I press escape there, says that all we really get is the timestamp, an X, a Y, and a Z. So that one can be X. And then all I can really do here is grab the contents of this, paste it a couple of times, and just make the changes for the Y-axis label and the Z-axis label, which not surprisingly just need to be slightly different. So all I need to really do is duplicate this line for the Y-axis label and the Z-axis label, getting the values from acceleration.y and acceleration.z. And this should really do it. I'm going to save this and compile. And going ahead and running it, we're installing it in the simulator. But we're going to run into a significant problem. There is no accelerometer in the simulator, so it's not actually going to send us anything. So to actually test this code, I will actually have to do it in the device itself. I'm going to have to connect the device and change my build and what I'm running this on to the iPhone device itself. Now, obviously, I can't do a screen capture of that, but this is the general process for connecting to the accelerometer. But to have any meaningful information, we're going to have to take it and install it on the device itself. But again, that is the general process. We grab hold of the shared accelerometer, we set the delegate of it, we set its update interval, and then respond to accelerometer : did accelerate.